Bismillahirrahmanirrahim. Assalamu alaikum, dear students. How are you? I hope you'd be fine. This is Cambridge Lower Secondary Book 7. Today we are going to start chapter number 8, which is related to shapes and symmetry. We are going to discuss about polygons in some other video, but today we are going to focus on lines of symmetry and rotational symmetry. So first of all, let us understand that what is line of symmetry. So basically, we have two types of lines of symmetry. Basically, we have more than two types of lines of symmetry, but if we talk about two lines of symmetry that are vertical and horizontal. So vertical line is a straight line coming from top to bottom, and the horizontal line goes straight side by side. Okay. And if we talk about that, what is line of symmetry? So to keep it simple, we can say that when you fold a shape along its line of symmetry, one half of the shape will fit exactly on top of the other half of the shape. Let us take an example of this rectangle given in part A of question number 1. In question number 1, what we have to do, we just have to copy each of these shapes and draw on them the lines of symmetry. That is, how many lines of symmetry can fit into it. So if I will draw this line of symmetry right in center, right? So what will happen? Like this. So if I will fold it like this is a triangle, and when I will fold it, I will fold this half on top of it. So what will happen? This shape would look like this. Like the one half of this shape will fit exactly on top of the other half of the shape. So that is why this line that I have drawn in between is a line of symmetry, right? So if we talk about this rectangle in particular, we can say that it has two lines of symmetry. How? Because it has a vertical line of symmetry and also a horizontal line of symmetry as well. Because if I will fold it from bottom to top or from top to bottom, it will again give me two exactly same halves. Okay. Similarly, we have an oval. So if I draw a line of symmetry like this, or if I draw a line of symmetry like this, so I will get, when I will fold it into in half like this, so first I will get a shape like this, two halves, and then I can further fold it like this. So I will get four equal quarters. So that's why we will have two lines of symmetry. But when we talk about this arrow in part C, we will have only one line of symmetry like this. Similarly, if we talk about part D, we have one line of symmetry, then two line of symmetry. Basically, we already have two lines of symmetry in this, but we can draw a few more. 3, 4, and in this way, we can draw unlimited lines of symmetry. But since we already have two lines of symmetry in this, so we cannot draw unlimited lines of symmetry. But for a circle where we do not have any other characteristic or any other attribute in that particular circle, we can say that we have unlimited lines of symmetry in a circle. But for a circle which have something else apart from the shape, then we cannot say it has unlimited lines of symmetry. So for this circle, we can say that we will have four lines of symmetry, right? Then if we talk about this arrow, two-sided arrow, again, we will have two lines of symmetry, 1 and 2. For this shape, we will have only one line of symmetry. We cannot draw a vertical line of symmetry because we do not have the equal edges on either sides. So we cannot draw a vertical line of symmetry. Then in this shape where we have two different triangles, one on top of other. So this is one line of symmetry and this is one more. We have two lines of symmetry over there. And then we have only one line of symmetry in this shape where we have a sort of semicircle. It's not a semicircle exactly, but it's a curved shape. And then comes this is smiley face. So we can draw only one line of symmetry over it. We cannot draw this line of symmetry because we have two eyes, two circles on top and a smiley face on its bottom. So we cannot draw a horizontal line of symmetry over here. Then in part J, we have again two lines of symmetry, one horizontal and the other vertical, right? And then we have two arrows going in different directions. So we will have only one line of symmetry like this. Then in a square, we have one horizontal line of symmetry, one vertical line of symmetry, and then two diagonals as well. Because in a square, since all four sides are equal to each other, so we can fold it like this and we will get exactly two similar triangles. So we will have four lines of symmetry in a square. Now, in question number 2, they are saying for each shape in question number 1, write down the order of rotational symmetry. So first of all, let us understand what is order of rotational symmetry. So let's take an example of a rectangle. Okay, it's a rectangle I have. Order of rotational symmetry means that the number of times a shape looks the same as it is rotated through one full turn. Like let us take this one as the starting point. Okay. So if you will rotate this rectangle once, the shape would be the same, but it won't look exactly the same as it was before. And this is the first turn. Okay. Then I will turn it once more to 90 degrees. And now it looks exactly the same as it was in the first place. Then I will turn it one more time to the 90 degrees. So it will again do not look the same as its first shape. And then the last turn, that is the complete 360 degrees. So again, it will look the same. So upon uh, rotating it to 360 degrees, that is upon rotating it to a complete turn, or you can say a full turn, that is from where we started, we get back to that place. So upon giving it a complete full turn, I am getting it's exactly the same shape two times. So the order of rotational symmetry would be 2. But for every shape, order of rotational symmetry is different because it has different number of sides, and the order of rotational symmetry depends on the given shape along with its sides and the pattern given. So for a rectangle, since it has 4 sides, but not all 4 sides are equal, only the opposite sides are equal, so it will have order 2 rotational symmetry, right? That is how many times it looks the same upon revolving it or rotating it along its axis. So if you talk about the first shape, it's a sort of a rectangle. So it will have order 2 rotational symmetry. Then if we talk about this oval, so again, it will have order 2 rotational symmetry because it will look like this oval only twice upon rotating it 360 degrees. Then if we talk about this arrow, so this arrow will look only once the same upon rotating it to its full turn. It will have only order 1 rotational symmetry. Why? Let me show you. If we talk about this arrow, at first it will look like this. Then when we will rotate it 90 degrees, it will look like this. Then it will look like this. And then it will look like this. And at the end, only it will look like the same as it was in the first figure, right? So it has only one order rotational symmetry. Then if we talk about this circle, so it will have order 4 rotational symmetry. Why? Because every time when I will revolve it to 90 degrees, it will look the same because it has two lines, which is dividing it into 4 equal quarters. So if I will rotate it to 90 degrees, again, it will look the same. When I will rotate it 180 degrees, it will look the same. When I rotate it furthermore, so it will look the same. And then at the end, it also looks the same. So the order rotational symmetry would be 4. Now, again, since this arrow is different from that one in part C, it has 2 arrows on the either sides. So it will have order rotational symmetry of 2. Why? Because at first, when I will rotate it to 90 degrees, it will look like this. But when I will rotate it further more 90 degrees, that is from the start to 180 degrees, it will again look like this. You see? So it will look like this twice upon rotating it 360 degrees. So it will have order 2 rotational symmetry. Then if we talk about part F, so it will look only once to its original shape upon rotating it to a full turn. Then it will have order 2 rotational symmetry. You can see that at first it will look like this, but again, upon rotating it 180 degrees, it will look the same. And since the upper and the lower triangles are the same, so it will have order 2 rotational symmetry, because upon rotating it 180 degrees and then 360 degrees, it will look the same. Then if we talk about this edge, so at first it's going to look like this, not the same. Then it will look like this, again not the same. Then it will look like this, again not the same. And at the end, it's going to be looking the same. So it has only one order rotational symmetry. Okay. Now let's move to the next part. Okay. Next, we have a smiley face. So when I will rotate it to 90 degrees, it will look like this. Not the same. Then when I'll rotate it to 180 degrees, it's going to look like this. Not the same. Then when I'm going to rotate it once more, so this time it's going to look like this. Again, not the same. And at the end, when I'm going to rotate it once more, then at the end, we can say that it's going to look like the same. So it has only one order rotational symmetry. And for this sweet-like structure would look like this upon rotating to 360 degrees only twice. So it has order rotational symmetry 2. Because when I'm going to rotate it once like this, so it's going to look like this. Okay, not the same as before. But when I will rotate it to 180 degrees, again, it's going to look like this, which is quite similar. So it has order 2 rotational symmetry. Then when we talk about this part K, so it's going to look like this at first. Okay, and then when I am going to rotate it once more, so it's going to look like this, which is again not the same. And then it's going to look like this. In the third turn, and at the end, it's going to look like the same as before. So it has order rotational symmetry 1. And then if we talk about part I, since it's a square, so square has order 4 rotational symmetry. That is, in all 4 turns, it will look like the same. Now let's do question number 3 the same way we have done question number 1. Again, we don't have to draw the lines of symmetry. We just have to write down how many lines of symmetry do we have in each part. So if we talk about this regular hexagon, since it has 6 sides and all 6 sides are equal. So for these type of polygons where we have all the sides are equal to each other, they are called regular polygons. So it's a regular hexagon. In any regular polygon, the lines of symmetry depends on the number of sides. So since there are 6 equal sides in a hexagon, regular hexagon, so it will have 6 lines of symmetry. How? Let me draw it. 1, 2, 3, 4, 5, and 6. So these are the 6 lines of symmetry we will have in this one. Next, we have an arrow. And since we have only one pointed arrow on one side, so we have no lines of symmetry. We cannot draw a line of symmetry like this or this or this. So it has no line of symmetry in it. Then we have a regular 1, 2, 3, 4, 5, 6, 7, right? Since we have, 8 sides in this polygon and all 8 sides are equal to each other, so it's a regular octagon. Okay, and since it has all 8 sides equal to each other, so it will have 8 lines of symmetry in it. How? The same way. 1, 2, 3, 4. 4 lines of symmetry in the sides and then 4 lines of symmetry in the corners. 5, 6, 7, 8. This is how we will have 8 lines of symmetry in it. And then if we talk about this D, it is a sign of a thunder, but it has no lines of symmetry in it. Okay, so we'll write 0. In these two shapes, we have 0 lines of symmetry. Then we have a symbol of sun, where we have a circle along with 1, 2, 3, 4, 5, 6, 7, 8 triangles. So again, it will have 8 lines of symmetry, just like that in an octagon. So you can draw lines of symmetry like this. 1, 2, 3, 4. 4 lines of symmetry. And then along these triangles, so it will be 1, 2, 3, and 4. So it becomes 8 lines of symmetry. Then we have a regular pentagon where we have all 5 sides equal to each other. So we will have 5 lines of symmetry in it. 1, 2, 3, 4, 5. In this pentagon, what will happen? That we will have the lines of symmetry from the side, the center of the side to the opposite edge. This is how we will have the lines of symmetry. And you can see that when we will fold it into its half, it will be like this. It will look like this. Each of the lines of symmetry. And then we have a square along with arrows on every side. So we will have 1, 2, 3, and 4. 4 lines of symmetry. Because when we will fold it straight, we will get a shape like this. Looks like this. Somehow. Okay. And when we will draw a diagonal line of symmetry, so it will look like this. This is how it's going to look like. Okay, so we will have 4 lines of symmetry in it. And in part H, since we have 2 curved sides and only one is straight side, so we will have no line of symmetry, because if we will draw a line of symmetry like this, and when we will fold it, we will not get 2 equal sides. Again, if we are going to draw a line of symmetry like this, again we are not going to get the same identical shapes. So we will have only one 0 line of symmetry in this part H. Okay, and after that, in question number 4, it says for each shape in question number 3, write down the order of rotational symmetry. So for the regular for the regular polygons, we will have order of rotational symmetry according to the number of sides they have. Like if we have 6 sides in a hexagon, so we will have order 6 rotational symmetry in part A. Similarly, in part C, there are 8 sides, so we will have order rotational symmetry of 8 in part C. And in part F, we will have order rotational symmetry 5. In part E, we will have order rotational symmetry 8, right? And if we talk about part B, so we will have only one line of one order rotational symmetry, because it will only look the same upon rotating it completely. That is, upon rotating it to 360 degrees. And if we talk about part D, again, it will have only one order rotational symmetry. And then if we talk about part G, so in part G, we will have order rotational symmetry according to the number of lines of symmetry, that is 4, because upon rotating it every time to 90 degree, we will get the same shape, same sort of shape. And then in part H, we will get this exact shape upon rotating it once 180 degrees, and then again upon rotating it to complete turns, that is 360 degrees. So it will have order 2 rotational symmetry. So this is how we have to identify, that is, what would be the order rotational symmetry and the lines of symmetry any given shape has. So we have completed till question number 4. Inshallah, we are going to do a few more questions in the next videos. Until then, take care. And if you are new to my channel, do subscribe to my channel. Don't forget to share it with your friends. Allah Hafiz.